Am I audible? Just check if I'm audible. Huh. आएगा आवाज एक बार चेक कर. Hello students. So today we are going to do a one shot revision plus previous year questions of Newton's laws of motion, and in that chapter we also have friction as well as circular motion. My name is Rahul Moore, and let us begin this session. So what are the topics that we will cover today? We will cover the laws of motion, we will cover friction, and we will see the dynamics of circular motion. So these are the topics that we will be covering today. Let us begin. The first law, the first law of motion. So it states that, in simple words, it states that if a body is at rest, it will remain at rest. And if a body is moving with a constant velocity, it will continue to do that. It will continue to move with constant velocity unless and until it is acted on by some unbalanced external force. Okay, so as you can see here, a body at rest or moving at constant speed in a straight line remain at rest or moving with the in the straight line at constant speed unless it is acted upon by a force. Now the first law gives us idea of something known as inertia. Something known as inertia. Now inertia, inertia is that tendency of a body to resist any change in its state of rest or uniform motion. So every body has a tendency that if it is at rest, it wants to stay at rest. If it is moving with a constant velocity, it wants to keep moving with the same constant velocity. Okay, this property is known as inertia, and mass is a measure of inertia. More the mass of a body, more is its inertia. So mass is a measure of inertia. Okay, now inertia can be described or divided into three types. First is inertia of rest. This is the tendency of a body to remain at rest. A body at rest tries to remain at rest. Inertia of motion. A body moving with a certain speed wants to move with the same speed. And inertia of direction. If a body suppose is moving north, it will keep moving north, keep moving in that particular direction unless it is acted upon by an external unbalanced force. Now there is a question for you. Which thread will break if force is applied slowly and if force is applied suddenly? So if you see here, this is an object hanging by a thread. Okay, let us assume the mass of the object is m, and we are pulling So this is another thread below it, and from here onwards we are applying a force F. But if we apply it slowly, slowly, then which thread will break, the upper one or the lower one? And if we apply the force suddenly with a jerk, then which of the threads will break? Okay, so this question is based again on inertia of rest. Now, when the force is acting here, the force, the tension in this string is, let's say, T, which will be equal to F. But this thread is also managing the weight of the object. So here the tension T dash will be this force plus mg. This string has higher tension, it is more taut, but this string has lower tension. Now, which has a chance of breaking if you pull it suddenly? Now, if you pull this suddenly, the due to inertia of rest, this tries to remain at rest, whereas this will suddenly snap. So what will happen here is, if you are pulling at this point, the top part of the string wants to remain at rest because it is connected to that object, and the lower part of the string moves with the force, so this lower string will snap. So if the force is applied suddenly, lower string will snap, and if you apply the force gradually, slowly, and slowly you are increasing the force, then this tension is always higher than this tension. Okay, so once it reaches its breaking point, this tension will always be higher than this tension, hence this string will break. So if the force is applied slowly, the upper string will break first. So I hope this is clear. There is another question for you. When an object is at rest, which of the following options are correct? So first option says force is required to keep it in the rest state. No, from first law, object at rest stays at rest unless unbalanced force acts on it. So this is incorrect. When an object is at rest, no force is acting on it. This is also not correct. For example, if I take a block and I apply equal forces from both sides, net force is 0, right? Net force is 0. So we cannot say, and the block will be at rest. Net force is 0. No force is acting on it is incorrect. Balanced forces may be acting. Third option, a large number of forces may be acting on it which balance each other. Yes. So this seems to be the correct option. And the fourth option is again incorrect. Moving along. Now, let us know about momentum. What is momentum? Momentum, in simple words, is just the product of mass of a body and its velocity. So, momentum is also a vector quantity, mass into velocity. What is its unit? Its unit will be kg meter per second. Okay, I hope this is clear. So, there's a small question. We have to find the change in momentum if ball rebounds with the same speed. So a ball has come mass m, speed v, and after collision it is going to rebound with the same speed. We have to find the change in momentum. So What is the initial momentum? Considering right side as positive direction and left side is negative, initial momentum is this way, so mv plus positive value. What is final momentum? mv again, but this side, so I should write minus mv. Yes. So what is the change in momentum? Final minus initial. If we do this, we will get minus 2 mv. The minus indicates the change is in this direction. So the change of momentum is in this direction. A very simple question. I hope this is clear to everyone. Okay. Next topic is impulse. Now, what is impulse? Impulse, in very simple words, means a jerk, okay? A sudden jerk. For example, when a batsman hits a ball, so the time of contact of the ball and the bat is very less. The time of contact of the ball and the bat is very less. But in that very less time, a large amount of force is imparted to the ball. Correct? So impulse is a jerk. Okay? Sudden jerk. So impulse is nothing but a sudden jerk, or if you see, we can also, in better way, we can say it that when a large force acts for a small time, large force acts for a small time, okay, then we talk about impulse. Now, impulse is denoted by J, and it's a vector quantity. And what does it equal to? Okay, it is equal to integration force dt, the force which acts during that small time interval, integration of that force with dt. There are other ways of writing this. We can also write this as the average force which acts in that small time duration multiply by that small time duration. There is another way to write the impulse, and it is also equal to the change in momentum. That means final momentum minus initial momentum. Okay, this is equal to final momentum minus initial momentum. So this is the formula of impulse, and we have to memorize this formula as it is very, very important. Yes, mostly what we use is either this or this for impulse calculations, and its unit is same as momentum because it is equal to change in momentum. So its unit is same as momentum, kg meter per second. Another way of writing its unit is force into time, so we can also write it as Newton into second. Now if you remember, in the previous question they had asked us change in momentum. If they had asked us impulse, this is only the answer for impulse as well. Yes, because impulse is nothing but the change in momentum. I hope this is clear. Let's see this question. So the question is saying that a rigid ball of mass m strikes a rigid wall at 60 degree and gets reflected without loss of speed as shown. So it strikes with v and again goes with v. The value of impulse imparted by the wall on the ball will be. how much impulse will get imparted by this wall on the ball which is striking it. We know impulse is nothing but change in momentum, but vector difference. So we have to be a little careful. If you see, this is the initial momentum. The direction of initial momentum is like this: mass m, speed v. And if this angle is 60 degree, this angle is also 60 degree, alternate angles. So what can I write the initial momentum? mv vector. Now v vector, if we resolve this vector, we will get cos component and sine component. So this is v cos 60. V cos 60 is v by 2. This is v sine 60, which will be root 3 v by 2. So the initial momentum can be written as m v by 2 I cap. Okay. Um, yes, m into v by 2 I cap, because this is in the positive x direction and this component is in the negative y direction. So minus root 3 v by 2 j cap. Now let us similarly write the final momentum. So if you see here, the final momentum is like this: mass m and speed is v, and this value is 60 degree. We again have to take the components. If we take the components here, this is v cos 60, which is v by 2, v sin 60, which is root 3 v by 2. So final momentum can be written as final momentum. Let me use that color. Final momentum will be written as m. X component is in the negative x direction, so minus v by 2 I cap. Y again negative y, so minus root 3 v by 2 j cap. We have our initial momentum and our final momentum. So what is impulse? Final momentum minus initial momentum. And if we put these values, if we put these values and solve it, we will see that this component will get cancelled and this will get added, and the answer will come as minus mv I cap. Minus mv I cap. Okay. So if you see here, the answer, they are just asking us the magnitude. So the magnitude is mv, hence the answer here is option A. I hope this is clear, everyone. All right, let us move forward. Next, we have Newton's second law. So Newton's second law states that the external force acting on any body is proportional to the rate of change of momentum. So in simple words, external force is just equal to dp/dt. Okay, and if we talk about average force, then we will write it change in momentum by change in time. Now momentum is m into v, so we can write it ddt of m into v. Using the product rule for differentiation, we can write it like this: Yes, this is the formula, which is the main formula. But in most of the cases, mass is constant. In most questions, mass is constant. So dmdt will become 0 because mass is constant. So the force is just equal to m dv by dt. And we know dv by dt is acceleration. Yes. And in some questions, you will see that the speed remains constant, but the mass is changing. Okay. And in that questions, dv dt becomes 0 and the force will be written as v dm dt. Okay. But in most questions, this is what we are using because mass remains constant in maximum questions. Let us also talk about equilibrium. So first we have translational equilibrium. What is translational equilibrium? Net force should be 0. If net force is 0, obviously acceleration is also 0, and this is known as equilibrium. Yes, why is acceleration 0? Obvious, F equals to ma, F 0, so acceleration also 0. Now, acceleration 0 does not mean that the body has to be at rest. Acceleration 0 means either speed is 0, velocity is 0, okay, continuously the body is at rest, or another possibility is velocity is constant because acceleration is dv dt. Acceleration is dv dt. Acceleration will be 0 when either v is 0 or v vector is constant. Okay, so two possibilities. When the body is at rest, the equilibrium has a special term known as static equilibrium. Whereas if the body is moving with constant velocity, then also the body is in equilibrium, and it is known as dynamic equilibrium. Let us try to do this question. Here they are saying that we have a body of mass 1 kg. It is acted upon by two forces. Both forces have 10 magnitude. We have to find its acceleration. We know acceleration is net force by mass. And if we talk about magnitude, we will just take the magnitude of net force. We need to find the net force here. If we apply the formula for vector addition, this is the net force, which will be magnitude for which will be given by under root a square plus b square plus 2ab cos of the angle between them. Okay, cos 120. How much is cos 120? Minus half. And if you solve this, net force will come out as 10. Net force is also 10. Hence the acceleration, net force is 10, mass is 1 kg, is just 10 meter per second square. So I hope this is understood, everyone. All right. Next, we have another question. Momentum as a function of time is given to us. Okay. Here, momentum as a function of time is provided. We have to find the force acting on the particle at 3 seconds. We know that force is equal to dp by dt. Momentum is given to us. What is it? 2 plus 3t square. Now, if you differentiate this, 2 differentiation is 0 plus 3 ddt of t square. So 3 ddt of t square is 2t. So answer comes out 60. But now they are asking at 3 seconds. So you put the value here 3. The answer which we get here is 18. So the correct option is option A. Yes. Okay. Now coming to Newton's third law. Newton's third law states that every action has its equal and opposite reaction. Every action has its equal and opposite reaction. So, if I suppose push a wall, the wall pushes me back. Okay. If I apply a force on an object, the object will apply the same equal and opposite force on me as well. This is action reaction forces, action reaction pair. For example, suppose this is Earth and a block is placed on it of mass m. Now, the Earth attracts the block towards its center, but how much force? mg. Newton's third law. The block also attracts the Earth towards itself by the same amount of force. Every action has its equal and opposite reaction. Okay. And I am sure you may know about normal force, but we will talk about it. Okay. We know that from Earth there is another force exerted on the ball, on the object known as normal reaction. Okay. Newton's third law, the object will also exert an equal and opposite normal reaction force. So don't worry if you do not know about normal reaction, we'll cover it shortly. So this is basically Newton's third law. Every action has its equal and opposite reaction. Let us see this question. So two statements are provided and we have to choose the correct options. First statement says, a cloth covers a table, some dishes are kept on it. The cloth can be pulled out without dislodging the dishes from the table. Okay. Statement 2, for every action there is an equal and opposite reaction. So statement 2 is third law. It is correct. Statement 1 is also correct because you may have seen this. A waiter or somebody pulls out the cloth quickly from the table. The dishes, they don't fall off, right? This is due to inertia of rest. The dishes are at rest and they have a tendency to remain at rest. Okay. So this is explained by first law. Inertia is explained by first law, whereas statement 2 is third law. So although both are correct, but statement 2 is not correct explanation. So here the answer should be option B. And this question was asked in JEE Mains Exam 2007. Although this session is for NEET students, but you must know this, that JEE Mains and NEET are approximately at the same level. Some questions of JEE Mains after some years are also repeated in the NEET exams. Okay, I hope this is clear to everyone. Now let us come to classification of forces. So There are broadly four classification of forces: gravitational force, electromagnetic force, nuclear force, and weak force. But we are not going to go into that. We just want the forces which we require in this chapter. The first is the field force mg. I hope everybody knows about this. So if in any question we say a block of mass m, a object of mass m is placed, whatever, one force is going to act, which is mg. Okay, this is the gravitational force due to the gravitational pull of the earth, and this force acts towards the center of the earth. So this is, let's say, the earth, and if we put a block here, this force will act towards the center. If we put a block here, the mg will again act towards the center of the earth. Coming to the next force, contact force. Normal reaction. This is a type of contact force. It arises due to contact between two bodies. Here, if you see, the block will experience a force mg downwards. This block wants to enter the ground and reach to the center of the earth, but the ground does not allow it. So the ground exerts an equal and opposite normal reaction. Okay, so normal reaction arises to prohibit motion in a certain way. So if this is a contact surface, if you see this is the contact surface, normal reaction will always be perpendicular to the contact surface. Okay, and such that it tries to inhibit the motion of two objects through each other. If normal here does not balance this force, this will enter, right, which is not allowed. So I hope this is clear. Normal is a kind of contact force which arises due to contact between two bodies, and it acts perpendicular to the contact surface. And how much is its value? Such that it inhibits motion, so that the two bodies do not go through each other. So the normal reaction in this case obviously is equal to mg. Okay. Next is something known as free body diagram. So free body diagram is just a technique to resolve a complex diagram into a simpler one. So again, let us take the same example. Mg force is acting downwards, whereas the normal reaction is acting upwards. If I were to draw its FBD, I will draw the entire object. I will represent it by a single point. So instead of drawing the entire block, I will just draw it by a single point. Now I will draw all the forces which are acting on it. So mg force is acting on it, as well as normal reaction is acting on it. We draw the forces as such, and then we can do our calculations. For example, in this case, the normal is balancing the mg, so we can write it in this manner. So this is an example of FBD. Nothing much, just draw the object by a single point and draw all the forces which are passing through that or which are acting on that object. A very simple question. We have to find the acceleration of this block. If you see a force F, 10 Newton is acting on a block of mass 5 kg. Hence its acceleration can be very easily found as force by mass, which will come out as 2. Okay, very simple question. So in this question, let's say that the topmost block has a mass of 1 kg, this block has mass 2 kg, and this block has mass 3 kg. And suppose the normal reaction here is Na, Nb, and Nc, and we need to find the normal reactions. All right. So let us start by drawing the forces which are acting here. So I know mg, which will be taking g as 10. Mg is 10 here. Here mg is 20, and here the mg is 30. Now, how will normal act? Normal at this surface is known as Na. So Na will act like this. But this is the normal acting on A by B. B is exerting this force on A. Newton's third law. A will exert equal and opposite force on B. Okay. On this surface, normal due to this surface is NB. It is acting on B as well as C. Newton's third law. It acts on both bodies. And here, if you see, normal due to C and this surface, and again NC. But this is not of any use to us because this force is acting on the ground. Now let us draw the FBDs. Let us draw FBDs and try to resolve it. So if I draw the FBD for A, what are the forces acting on it? A force acting on it upwards is Na, and a force mg equals to 10 is acting downwards. Net force is 0, so I can simply balance the forces. Na is equal to 10. Let us draw the FBD of B. If you see here, what are the forces acting on B? Upward force is NB, whereas downward forces are Na and 20. So normal reaction Na plus 20 is the mg. Na we have already found, it is 10. So this equals to 30. Now it is in equilibrium, so net force must be 0. NB is 30. Now making the FBD for C. If you see here, 30 and NC are acting downwards. I'm sorry, this should be NB. 30 and NB are acting downwards, and one force NC is acting upwards. NB is 30, we have calculated, so this whole becomes 60, and this is balancing this 60. So normal at C, NC becomes 60. So in this way, you can make FBDs and solve such questions. I hope this is understood and clear to everyone. Okay, someone is asking about friction. We will cover that. Okay, as we go in this, slowly we will cover friction and circular motion as well. Do not worry. All right. Going forward, in this case, we have to show the forces which are acting. So we know this force is acting here. Mg will act. Mg is going to act. Let's say M1G. Normal N1. And here M2G. Normal N2. But if you see, there is a contact surface here as well, and there will be forces acting, which will be normal reaction. So a normal will act on M2 as well as M1, okay, due to Newton's third law. So these are the forces which are acting on the two bodies. So we have three normals, N1, N2, and N, two mg's and one external force F. Let us try to solve this question. If you see here, we have to find the accelerations of both the blocks A and B and the normal reaction between A and B. This is 30 and this is 15. Obviously 30 is bigger than 15, hence their acceleration will be towards the right. And obviously both of them will remain in contact and move with the same acceleration. So accelerations of A and B are going to be the same. Okay. We have to find this acceleration. So one method is we draw the FBDs, write the forces, write the equations and solve it. But in entrance exam, we have less time. So let me tell you a shortcut for this. For acceleration, there is a very good shortcut. You consider this like a one body. Consider this like a system, as a single body. If you do that, if you consider this like a system, then A plus B is a single body. And how much kg does it become now? 15 kgs. How much kgs? 15 kgs. 10 plus 5, 15. What are the forces acting on it? F1 is acting towards the right. How much is this? 30. F2 is acting towards the left. How much is this? 15. Correct? Now, what about the internal normal reaction? What about this force? When we draw combined FBDs, okay? When we draw combined FBDs of two or more bodies, we do not draw internal forces. Internal forces need not be represented here. So no need to consider this. Another thing, mg will be 50. It will be balanced by a normal here, 50. Mg here is 100, another normal here 100. Those are already balanced. Those are not of any importance to us. That is why we have not drawn those forces. What is importance is this direction forces. Now the acceleration is to the right. We know net force equals to mass into acceleration. What is the net force? 30 minus 15. 30 minus 15. What is the mass? 15 kg into acceleration. Acceleration comes out as 1. Yes. So I hope this is clear to everyone. So this is a way to find the acceleration without writing equations for both the blocks. But another thing they have asked us is the normal force between the blocks. To find this force, we have to either take the FBD of A or the FBD of B. Any one will give us the right answer. Let us make the FBD of B. If we make the FBD of B, we can see that it has mass 10 kg. Again, the vertical forces are not of any significance here in this question, so we are not drawing that. On the left, we have 15 Newton, and on the right, we have normal reaction N. And we know acceleration we have calculated as 1. So we will now say net force equals to mass into acceleration. Net force is N minus 15 equals to mass is 10 kg, acceleration is 1. So from here, normal reaction comes out as 25. So this is the answer. The same normal reaction can also be obtained by making an FBD of A, which you can try later. All right. Let's move forward. So this is another question. Not exactly a question, but we have to write and draw all the forces which are acting here. This is known as an inclined plane. This theta angle is the angle of inclination. What are the forces acting here? So we have mass mg acting downwards, vertically downwards, and we have normal reaction acting perpendicular to contact surface. This is the contact surface, so perpendicular to it, normal reaction will act. These are the only two forces here. Okay, but we should also know how to balance these forces and everything. So if you think about it, acceleration is going to be in this direction. Acceleration is going to be in this direction, and it is a good practice to break the forces along the direction of acceleration and perpendicular to it. So what we are going to do is we are going to break all the forces in these two directions. If you see, normal is already in this direction, so no need to break it, but mg needs to be broken. Here this angle is theta, so again this angle is theta. Okay, by simple geometry. And now if we break mg, we will get two components, one here mg cos theta and the another component here as mg sin theta. And now we can balance this normal reaction with this. So the normal reaction comes out as mg cos theta. But there is no one to stop this. No one can stop this force now. Nobody is there to balance it. This force will make it move downwards and bring some acceleration to the body. We can write this force equals to mass into acceleration. This is the net force which is acting on the body. So acceleration of the body becomes g sine theta. Okay. So we found the normal reaction and the acceleration in this particular case. I hope this is clear, everyone. We should know how to break the forces and how to write these equations. Moving forward, we have to find the tension in the string. We need to find the tension in the string here. So tension is another contact force. It acts in strings and rods. And how does it act? So on this block, the tension will act along the string like this. This is acting on this block. And similar equal and opposite tension will act on this block. Okay. So these are the forces which are acting in this particular case. So tension pulls both the bodies. Okay. It exerts force on both the bodies to which it is connected, to which the string is connected. Let us see a simple question. We have to find the acceleration of the blocks and the tension in the strings. Okay. So again, there will be different tensions acting at in different strings. So let's say the tension acting here is T1 and the tension acting in this is T2. Okay. We have to find both the tensions and we have to find the acceleration. Now, all these bodies are going to move together. with the same acceleration. As they are connected, they will move one after the other together with the same acceleration. So again, we can consider them a single body. If we consider them a single body, then we can see the net mass is 50 kg. Okay, net mass is 50 kg, and T1, T2 are internal forces. We will not draw them, so only external force 100 is acting. It will create acceleration. We can write this force as mass into acceleration. Acceleration comes out as 2. Once we got the acceleration, now we can draw FBDs. Let's draw any two FBD. Let's see. Let's first start with A. So if I draw FBD of A, I can see the mass is 20 kg. Again, vertical forces we are not drawing. Mass is 20 kg. The force acting is just T1, and the acceleration is 2. So we can write force equals to mass into acceleration, and it will come out as 40. T1 is 40. Now we can draw either FBD of B or C. I choose C. So for C, if you see here, there is 10 kgs. Force acting F towards the right is 100, and towards the left T2 is acting, which is unknown. Acceleration is again 2. Yes. So what we can write here is net force equals to mass into acceleration, which brings T2 as 80. So I hope this is clear to everyone. So another question here, and this is a string pulley system. Find the acceleration of the blocks and the tension in the string. Also find the force exerted by clamp on the pulley. So let's do this. So if you see here, the mg acting here is 20, tension let's say is T. Here the mg acting is 30, let's say the tension is T. Same string, same tension. Obviously this 30 will go down, this is heavier. Let's say it goes down with acceleration A, then this will also naturally move up with acceleration A. Now let us write the equations. So first I write the equation for A. If you see 30 down, T up, acceleration down, so net force is 30 minus T equals to mass into acceleration. For B, if you write it, what will we write? T minus 20 equals to mass into acceleration. Now we can easily solve this. We can solve this. If we add the two equations, which brings us acceleration as 2. Okay. And if we put in any one equation, let's say in this equation, if I put the value of acceleration, we get the answer of the tension. So I hope this is clear to everyone. String pulley question, a very, very common kind of question. All right. There is another way, by the way, here to find the acceleration a little faster. So the other way, second method of finding the acceleration is again we write acceleration as net force which is pulling the system by total mass of the system, and we ignore internal force which is tension. So if you see, this A block has mg 30, but the B block has mg 20. 30 this side, 20 this side, they are opposing each other. So the net force is 30 minus 20 because it will move like this. So 20 is trying to move it in the opposite sense. 30 wants it to move in the opposite sense. So the net force should be written as 30 minus 20, and the total mass here is 5 kg. So the answer comes out as acceleration as 2. But to find the tension, you have to draw any one FPD. I hope this is clear, everyone. Let's move to another question. In this question, again, we have to find acceleration and tension. Again, we have to find the acceleration and tension. So if you see, this moves down with acceleration A, this moves to the right with acceleration A. Tension, tension is acting, mg is 20, but here the mg is getting balanced by normal. So there is no use of this force here. It is getting balanced. If I try to find the acceleration directly, what will I write here? Acceleration net force by total mass. What is the net force which is pulling the system? 20. If you see, this system is like this and it is going to move like this. Which is responsible for this? This 20 is pulling it. Tension is internal. We will not consider that. This mg is getting balanced by normal. We will not consider that. So this 20 is the net force pulling the both the blocks. And total mass getting pulled as 5 kg. So it comes out as 4. Is that clear, everyone? Acceleration is 4. Now we can find tension very easily. Any one FBD. Let's make this FBD and the equation and solve. So we will write net force mass into net force is 20 minus T. This is the net force equals to mass into acceleration. Acceleration we calculated as 4. So this becomes 8 and tension becomes 12. So I hope this is clear to everyone. All right. Next, let us go and see, go into the concept of pseudo force. But before that, we should know what is an inertial frame of reference, what is non-inertial frame of reference. So, what is frame of reference? It is the frame from which you are observing the motion. From which you are observing the motion. If you are on a ground, you are standing on the ground and you're watching a motion, then you are in the ground frame. If you are in a car and you are watching the motion, you are in the car frame. If you are in a train and you are watching the motion, you are in the train frame. Okay, so frame of reference is just the frame from which you observe the motion. What is inertial frame of reference? Acceleration of the frame is 0. Then it is known as inertial frame of reference. Okay, frame from which you are watching is not accelerating. Suppose you are sitting in a car moving with constant velocity. You are in inertial frame. What is non-inertial frame? Acceleration of frame is not 0. Now, if you are sitting in a car and the car starts to accelerate, so now you are in car frame and the car is accelerating, you are in a non-inertial frame. Okay, so simple. Now, the thing is, in non-inertial frame of reference, there is an issue. The issue is Newton's second law is creating problems here. Okay. So in order to apply Newton's second law in this frame, we have to use pseudo force. Only for the reason to apply Newton's second law in non-inertial frame. It will not work unless we apply pseudo force. Now what is pseudo force? Pseudo force is nothing but mass of the body into acceleration of the frame. Mass of the body into acceleration of the frame, and its direction is opposite to the acceleration of frame. They are in opposite directions. Okay, this might seem a little confusing, so let us understand this better by an example. Look at the board. We have to find the angle made by the string with the vertical and the tension in the string. Okay, we have to find the angle made by the string with the vertical and the tension in the string. If you look here, the tension is acting along the string, mg is acting down. But if you imagine, if you're sitting in a car and there is something hanging from the rear view mirror, usually in India we hang certain things. Okay, so if the car accelerates, that thing which is hanging, which was hanging like this, when the car starts accelerating in this direction, that thing will become like this. I hope you have observed that. So this mass, which was initially this mass which was initially hanging in this manner will now become tilted. Will now become tilted. So tension is acting in this direction and mg is acting in this direction. Now suppose we are in this car. We are in the car frame. So what will we feel? We will feel that the car is at rest, because we suppose the car is enclosed, it's a completely closed from everything, no window, nothing. You will not feel that the car is moving, you will feel the car is at rest, and you are in a non-inertial frame. So what we have to do is we have to apply a pseudo force. We saw the value of pseudo force as mass into acceleration of frame. Mass of body, acceleration of frame, opposite to the acceleration of frame. So in this question, pseudo force will act opposite to the acceleration of frame. Frame is accelerating a naught here, to pseudo force will act opposite. Okay, and how much will it act? Mass of body m, acceleration of frame a naught. This much. Now we can resolve and see, this is what we have to find. Angle made by the string with the vertical. Net force here is 0 because this is in equilibrium at this angle. We can resolve tension here. This is theta, this is theta. So this is t cos theta and this is t sin theta. Now left equals to right, top equals to bottom for equilibrium. Left equals to right, top equals to bottom. Now we divide these two equations. If we divide these two equations, we will get tan theta as a by g. So what is the angle? It is tan inverse a by g. This is the answer. All right, let us move forward. Now, coming to friction. Friction is that force which opposes relative motion or tendency of relative motion. For example, if we have a block on ground and if we exert a force here, this block wants to go this side. The surface will exert a frictional force opposite because it does not like relative motion. Relative motion is this slipping. If both the bodies move together, there is no relative motion. But if one slips over the other, then there is relative motion. Friction opposes relative motion. This is the force acted on the block by the ground. Newton's third law. The block will also exert equal and opposite friction on the ground. All right. So this is friction in a nutshell. Now we will see what is static friction, what is kinetic friction, all those things as well. What is static friction? So friction is acting and it is trying to stop this block from moving. If friction is successful, if friction has stopped this from doing relative motion, then that friction will be called static friction. So it acts when pair of surfaces having tendency to relative motion. Okay, tendency to relative motion. They want to do, but they are not able to do the relative motion. Now, what is the value of static friction? So maximum static friction value is given as mu into normal reaction, where mu s into normal reaction. Mu s is coefficient of static friction, unitless and dimensionless. Okay, unitless and dimensionless. Let us see a question. A block of mass 2 kg is placed on the floor. So mg will act 20. Coefficient of static friction mu is given here, mu s is given 0.4. Force 2.8 is applied horizontally. What is the frictional force? So first find the maximum friction. It is, we know, mu s into normal, and here the normal will balance this mg. So normal is 20. Now this comes out as 8. Static friction has power of 8 Newton, but it will only apply the amount which is required. How much is required? The 2.8 is trying to pull it, so it will only apply 2.8. So what is the answer here? The force of friction is 2.8. Although if you calculate this thing, you will get the maximum power of static friction, but it will only apply the amount which is required. Another question. A force 10 Newton is acting here to hold a block stationary against a wall. Mu is given here as 0.2. We have to find the force of friction between the block and the wall. So if you see here, the normal reaction is 10. mg is not given. Okay. Oh, that is what we have to find. Mg, the weight of the block, we have to find. And where will the friction act? The friction will try to stop it. And they have used the word just hold. That means this is a critical situation. That means static friction is at its maximum value. Mu is 0.2, normal is 10. If you put the value, you will get this as 2. If this is 2 and it is balancing mg, therefore we can say mg is also equal to 2 Newton. So the answer here is option D. Yes? Any questions so far? Let me just check. All right. Let us move forward. Kinetic friction. So kinetic friction acts when the bodies are doing relative motion. Okay. There is no other choice for friction. Friction cannot stop them. And this is similar formula mu k into n. Mu k is coefficient of kinetic friction. Again unitless as well as dimensionless. All right. Next is contact force. Contact force is nothing but the resultant of friction and normal. Okay. So mg is acting, the external force is acting, friction is opposing the external force, and normal is opposing the movement in this direction. The net force of this two is contact force. So how much is the value of contact force Fc? Contact force Fc. It is just the net of these two forces. They are in perpendicular directions. So it is simply n square plus friction square. This is the contact force. All right. We will take a short break of 5 minutes and then we will continue this session. All right. Just 5 minutes short break and then we will continue with the circular motion part and then we will see some NEET previous year questions as well. All right. So let us now continue. We have done till contact force of friction. Now let us see a little bit of theory of circular motion. So in basic thing, we know that if a circular motion is taking place, there is one force which is mandatory for circular motion. Which is that? That is the centripetal force. Without centripetal force, there can be no circular motion. Centripetal force always acts towards the center of the circle which is taking place. What is the value of the centripetal force? Centripetal force value is given by mv square by r, mass into speed square by radius, and when it is rotating it also has angular velocity omega, and we know v equals to r omega. If you put this value here and solve, we will also get the value of centripetal force as m r omega square. So this is the main formula of centripetal force. In vector form, it is written as m into v cross omega. This is the vector form notation. So now we know we have the expression for centripetal force. Okay. So this is the centripetal force, it acts always towards the center. There is another force known as tangential force. Okay. Tangential force is a force which acts along the tangent. So suppose another force is acting here along the tangent, Ft, tangential force. Tangential force. It will always act towards the along the tangent to the circle. So tangential force. This force is given as mass into tangential acceleration. Just like this is mass into centripetal acceleration. This is mass into tangential acceleration. And this is equals to mr alpha. What is our radius of the circle? What is alpha? Angular acceleration. Okay. So from here we can see what is centripetal acceleration. It is simply v square by r, or r omega square. And what is tangential acceleration from here? It is simply r alpha. Okay. All right. Moving along. So tangential force which we just saw is this. We have seen this in the previous slide. Now what is the net force? If you see here, I'm sorry, if you see here, we have centripetal force and tangential force. Okay. Let me draw this same here. We have centripetal force like this and tangential force perpendicular to it. So the net force is just the vector sum of these two, Fc square plus Ft square. This is the net force. Fc is mass into centripetal acceleration. This is mass into tangential acceleration. If you put the values, you will get this. This is the net force. Okay. Okay. Then this is again centripetal force. Now comes centrifugal force. Okay. Let me see. Yes. So before we go to centrifugal force, this is again another slide depicting the forces, tangential force formulas, centripetal force formulas. Very, very important. What is centrifugal force? So, centrifugal force, suppose a body is doing circular motion. Suppose a body is doing circular motion. Then there is centripetal force which is acting. There is tangential force which could be acting, but we are now concerned with centripetal force. Who is watching this circle? A person which is standing somewhere else, let's say on the ground. So this motion is viewed from the ground. When it is viewed from an inertial frame, the ground frame mostly, then we talk about centripetal force. But now, the same circular motion, the same circular motion is observed from the body which is doing circular motion. Suppose this is an object and we sit on this object, and now we are seeing what is happening, we are looking at the motion. Now the thing is, this has acceleration, centripetal acceleration, right? So when we are in this frame, this is an accelerated frame, it has some acceleration. So we are in a non-inertial frame, which we studied a couple of slides back. We are in non-inertial frame, accelerating frame. So now we have to apply a pseudo force. A pseudo force which is opposite to the acceleration of frame. Frame acceleration here, pseudo force this side. How much is the pseudo force? Mass of this body and acceleration of the frame, which is AC. Pseudo force is mass of body, acceleration of frame, and opposite to the acceleration of frame. Acceleration of frame is this side, pseudo force is this side. This pseudo force is known as centrifugal force. Okay. So centripetal force, centrifugal force, people get confused, but it's very simple. We talk about centripetal force when we are viewing it from, let's say, the ground. But if you sit on the object which is doing circular motion, you are viewing the motion when you are sitting on that object, you are in a non-inertial frame. So a pseudo force has to be applied, and this pseudo force is known as the centrifugal force. Now we can put the values here. We'll get the same value, mv square by r equals to mr omega square as well. So this is known as the centrifugal force. I hope this is clear to everyone. All right, let us continue. So there are some differences between centripetal force and centrifugal force. So what are the differences? Centripetal force is directed along the radius towards the center. Centrifugal also along the radius but away from the center. Okay. This is a real force versus this is a pseudo force. It arises in both inertial non-inertial frames. It arises only in non-inertial frames. So there are some basic differences, but don't worry, NEET will not ask this kind of things. Let us see question. So this question says two bodies of equal masses revolve in circular orbits of radii r1 and r2 with the same periods. Time period is same. So omega is same. If time period is same, their omega is same. Their centripetal forces are in the ratio. So centripetal force is mr omega square, equal masses, equal omega. So centripetal force is only proportional to radius in this case. So what is the ratio of the centripetal forces? It is equal to the ratio of the radiuses. So here the correct option is option B. Yes, simple question. Now let's see another question. We have to find tension in the wire if ball is rotating with velocity v. So the ball has, let's say, velocity, tangential velocity is there v, and this is a string connected to the connecting the ball. We have to find the tension in the string. So if I draw a top view of this, what will we see here? We will see that a body is connected, let's say it has mass m, moving with speed v along a circle. So centripetal force acting here is T, tension T. Let us apply the pseudo force here, mv square by r. Let's say the radius of the circle is r, and now these forces are balanced. So the answer of tension here is mv square by r. This is the way we will solve such questions. We will apply centrifugal force and then equate the forces in the radial direction. Yes? Okay. So we have covered a lot of topics in theory here. We have covered the laws of motion, the three laws of motion. We have seen various questions that can be solved and created in those theory portions. Then we have seen friction. We have seen some questions that can be created there. And we have seen circular motion and some questions created here. uh, Obviously, as this is a one short video, every theory, every portion cannot be covered, but I have tried to cover as much as possible. And now the best part is, now we will see the NEET previous year questions. We shall see NEET previous year questions and we will just try to solve these questions. So the first question, and this was asked in the year 2025, last year. So please read the question and then we will try to solve it. All right. I hope all of you have read the question. So it's a good practice to draw a diagram. A ball is there. It has mass 0.5 kg. Dropped. So speed is 0. It is dropped from a height of, let's say h1 40. Now when it strikes, it will strike with some speed v1. Let's say v1. We can conserve energy from here to here. Potential energy got converted into kinetic energy. So one equation which I would like to write here is half m v1 square is equal to mgh1. I'm sure you know the basic energy conservation. So from here we get the value of v1 as root 2gh1. Now it says it rebounds, the hits the ground and rebounds to a height of 10 meter. So basically, after hitting the ground, the ball again has some velocity, let's say v2 upwards, and this time it is reaching a height of how much? 10 meter. That means here again the speed becomes, final speed becomes 0. Again, we can apply the energy conservation here. The kinetic energy got converted into potential energy. So we can write half m v2 square as mgh2, which will again give v2 value as root 2 gh2. So now we have both v1 as well as v2. We have both. But they are asking us impulse imparted to the ball. Now we know this. We have studied this in today's class. Impulse is nothing but change in momentum. And they are just asking us the value. We don't need to go into sign, positive or negative. But we have to take one sign. Let's say this is negative and the upper is positive. So initial momentum is mv1 minus mv1. Final momentum is plus mv2. Initial moment is minus mv1. So if you see here, it becomes this. All the values are available to us. M is given 0.5. Okay, M is given 0.5. V1 is root 2 GH1 and V2 is root 2 G H2. H1 and H2 are available to us, and G we can take 9.8 or approximately 10. If you take, you will get the approximate answer, then you can see which is the closest answer. If you solve this, you will get the answer of J as nearly 21. So the answer here is option A. All right. Beautiful question by NEET 2025. Next, another question. Please read the question, everyone. Let me see if there is any doubts in the chat. No, all good. Friction already covered. Okay. All right. Let us continue. A horizontal force 10 Newton is applied to a block A. Masses of blocks are given. There is no friction. We have to find the force exerted by A on B. Now see, this type of question we have done in class today itself. And this was asked in NEET 2024. And it's a very easy question. We have done this question, this type of question in class today. I can show it to you. We have done it. In fact, I think we have taken more than that blocks, maybe. Oh, see, look here. Similar question, we have done it today. Anyways, coming back to the question. We have to find force exerted by A on B. So we have to find the normal reaction. This will exert a normal like this. This will exert a normal like this. We can find the acceleration directly. We can find the acceleration by taking it as a system, right? What will be the acceleration here? Acceleration net force by total mass. Net force acting is 10 because normal is internal force. We'll not consider. Mass is 5, acceleration 2, right? And now we draw any one FPDs. to get the normal, either A or B. Whatever you like, you can draw. Let us take for B. If you see B here, it is having how much? 3 kg. Normal is acting to the right. Acceleration is also to the right. Vertical forces, no need to draw, not of importance, we can draw, but they do not serve our purpose. Now net force is equal to mass into acceleration. So the answer here is simply 6 Newton. And you see, this question was asked in 2024. Such a simple question. All right, let's just see the next question. A bob is whirled in a horizontal plane by means of a string with an initial speed of omega rpm. The tension in the string is T. If speed becomes 2 omega while keeping the same radius, what is the tension in the string? So when a string, if you revolve something, it is doing circular motion, and tension is the centripetal. Tension is the centripetal force. So tension value is mr omega square. Okay. This is the initial tension, which is called T here. Now they are saying find the final tension. Mass is same, radius is same, but the omega becomes 2 omega. So it is 4 mr omega square. Mr omega square is T, so this is 4T. So the answer is 4T here. Such a simple question. Yes. And this was asked also in 2024. Next question. Calculate the maximum acceleration of a moving car so that a body lying on the floor of the car remains stationary. A car is there, okay, and a block is lying on the floor of the car. Let's say block has mass in mg, normal is equal to mg. Now they are saying that this car is accelerating, and if we are solving from the perspective of car, from the frame of car, we will apply now a pseudo force. Yes, we know about pseudo force now. And this tries to go here. So friction is there, mu. So frictional force will try to stop it like this. Okay. Maximum acceleration. If this acceleration increases, becomes maximum, this force becomes maximum. So friction also needs to apply its strength, which is mu mg, mu into normal, mu mg. At equilibrium, this force must be balanced by this force. That is the critical condition till which the friction can balance it. So mass into maximum acceleration equals to mu mg. So the maximum acceleration comes out as mu g. Mu is 0.15, g is 10. Putting the values, we will get answer is 1.5. Option D is correct. And this question was asked in the year 2023. Not very tough. If you have practiced even a little bit of this type of questions, you will be able to do it. All right, let's go to the next question. So we have a shell of mass m, which is initially at rest. Now it explodes into three fragments. Okay, so we have a shell which has mass m. It has, okay, let me draw it a bigger one. We have a shell which has mass m. Now it has broken into three parts. Okay, one part, one more part, the one last part. Of ratio 2 is to 2 is to 1 mass. So total parts are 5. So this is 2 by 5 m. This is also 2 by 5 m. This is 1 by 5 m. This is how, this is ratio and proportions. M got divided 2 is to 2 is to 1 ratio. So 2 by 5 m. This is also 2 by 5 m. And this is 1 by 5 m. If the fragments having equal mass fly off along mutually perpendicular directions. Oh, so after it exploded, the ones which have equal mass, okay, they are flying across mutual perpendicular directions with speed v each. We have to find the speed of the third fragment. What is the speed? Let's say like this, v dash of the third fragment. How to do this? This is a common variety of question. Bomb explosion question. Here momentum is conserved. So initial momentum is equal to final momentum. Initial momentum is 0 because it was at rest. So final momentum is also 0. Final momentum is 0. When will final momentum be 0? Look here. It is only, see, the sum of three momentums has to be 0. So it is only possible if the sum of any two cancels out the third momentum. Okay, so try to imagine it like this. So we have two momentums. One momentum is like this, another momentum is in this direction. Their sum is going to be here, somewhere here. This is the momentum of sum of these two momentums. Okay, third momentum needs to balance this. They should be equal and opposite, the third one, because we are adding actually three momentums. The sum of two momentums should be balanced by the third momentum, then the net momentum will be 0. So if you think like that, you can do it in a faster way. So if you see, this momentum is mass into velocity. How much? 2 by 2 by 5 m v. This is also 2 by 5 m v. So what is their resultant? What is their resultant? Their resultant is root 2 times of, because you can do under root a square plus b square formula, 2 by 5 mv. This is the resultant of these two momentums. It is getting balanced by the third one. The third momentum is here. How much is that? Mass into velocity. This is balancing that. So we can say mass into velocity is equal to root 2 times of 2 by 5 mv. And this gives us our answer as 2 root 2 v. So the answer here is option D. I hope this process of solving is clear to everyone. And this question was asked in the year 2022. Yes. Moving forward. A small block slides down a smooth inclined plane starting from rest. Okay. Inclined plane smooth, no friction. Starting from rest. Okay, very good. Let S be n with the distance traveled by the block in this interval n minus 1 to 1. Okay, this is S nth. If you remember S nth formula, you may have studied in motion a straight line. It is u plus a by 2 into 2n minus 1. And u is given as 0. So it is just a by 2 into 2n minus 1. We have to take the ratio of Sn by Sn plus 1. It's a very simple question and it is a kinematics question actually. So Sn by Sn plus 1 is a by 2 2n minus 1 by a by 2. Instead of n we put n plus 1. Okay, a by 2 gets cancelled and the answer comes out as this. So the correct answer here is option A. Although I think this is a kinematics question and this was asked in the year 2021. Yes, I hope this is clear. Another question for us. Okay. Another question for us. We have two bodies, masses 4 kg and 6 kg, are tied to the ends of a massless string. The string passes over a pulley which is frictionless. The acceleration of the system we have to find. We solved this type of question. So mg here is acting as 60. Here it is acting 40. Tension is acting. Tension is acting. The acceleration, and in terms of acceleration due to gravity, so let me call it 6g and 4g. This is heavier, this will try to go down, this will try to go up. Acceleration is net force driving the system by total mass. So this is 6g minus 4g net force and total mass is 10. So 2g by 10 yani that is g by 5. So the answer comes out here as simply g by 5. We have done such a similar question in today's class. Okay. Okay. Again, similar question we have done today's class. We have to calculate the acceleration of the block and trolley. Coefficient of kinetic friction is given. Here there is friction. G10, mass of string negligible, no other friction exists. Okay. Again, a very simple question by NEET 2020. mg acting here is 20. And here if you see the normal reaction will be equal to its mg because the mg will act down 100, normal will act up and it will be equal to again 100. Yes. So friction will act here and try to stop it from moving. How much friction will act? So kinetic friction is mu k into normal reaction. Mu k is 0.05, normal is 100, so this becomes 5. So kinetic friction acting is 5. And there will be tensions also, but they are not asking us to find the tension, just the acceleration. Acceleration very simply, net force driving the system by total mass. Net force driving the system is 20 minus 5. So 20 like this and 5 that direction, 20 minus 5. And total mass is 12. Right? So we get the answer is 15 by 12 or 5 by 4 or 1.25. So the correct answer here is option D. NEET 2020. All right. Next question. A particle moving with velocity v is acted by three forces as shown by the vector triangle PQR. The velocity of the particle will increase, decrease, remains constant, or change according to the smallest force. This was asked in 2019, the year of Corona. Now, if you see here, let's say the forces are F1, F2, and F3. If you have vector knowledge, you would know from the triangular law or from the polygonal law of vector addition. If you place vectors such that they become a closed polygon, the sum of the vectors is 0. This is a property of vectors. So if you place vectors head to tail such that they form a closed polygon, triangle, quadrilateral, whatever, closed polygon, then the sum of the vectors is 0. If net force is 0, acceleration is 0, so velocity will remain constant. So here the answer is option C. All right. Moving to the next question. Which one of the following statements is incorrect? Incorrect statement. Friction opposes the relative motion. This is correct. We saw this. Limiting value of static friction, that means maximum value, is proportional to normal reaction. Yes, of course it is. Rolling friction is smaller than sliding friction. It is correct. Rolling friction is very low friction acting. Okay. We do not need to go into details. And next is coefficient of sliding friction has dimension of length. This is incorrect because it is dimensionless. We saw that when we saw that theory portion. So the correct option here is option D because we have to find the incorrect option. Okay. I hope this is clear. Moving forward, another question. This was in 2018. So a block of mass m is placed on a smooth inclined wedge ABC. Inclination theta. Wedge is given acceleration a towards right. Relation between a and theta for the block to remain stationary on the wedge. With respect to the wedge, it should remain stationary. So if this is the wedge and let's say this is the block, it should not slip on the wedge. Okay. That is what it means, stationary on the wedge. Okay, with respect to the wedge. So the best way is we will solve with the wedge frame, and so we have to now apply a pseudo force ma, and obviously mg is acting and normal reaction is already acting here. We have to find relation between a and theta. If you see the option a and theta are there, normal reaction is not there, we have to eliminate normal reaction. So now we will take components and balance the forces. So we break normal reaction this time. If this is theta, we know this is theta. So this angle is also theta. Geometry, basic geometry. So the components are these. Now we can balance it. Left equals to right, top equals to bottom. If we balance it, we are balanced. Now we can just divide to eliminate the normal reaction that is not there in the option. So we divide them. If we divide them, what are we going to get? If we divide them, we will get tan theta. Sine by cos is tan. M will get cancelled, A by G. Tan theta equals to A by G, or we can say A is equal to G tan theta. So here the answer is option D. Okay, 2018 NEET has asked this question, a very common question if you ask me. It's a very common question. All right. Next question. So if you see here, this was asked in 2017 and it's a very good question. Two blocks A and B are there of masses 3m and m, and they are connected by a string, and this is connected by a spring. Now this string is cut. The string we are cutting, we have to find the acceleration of each of the blocks. So let us try to solve this question. Look at the board. We have a spring and a block here. Let's say mass 3m, block A, and then a string, another block B, mass m. So first let's write the values of the tensions. So here mg, this tension is equal to mg. Here also it is acting. Then this is weight is 3 mg. So here the tension T dash is 4 mg because everything is balanced. Correct? Now this is cut. Just after cutting, what happens? This tension becomes zero because string is cut. But this mg is continuously acting. So this will fall by acceleration g. But what about the first block? This tension is zero, but this 3 mg is still acting, the weight. This 4 mg is still acting, the tension. So if you see here, the net force is upwards. How much is the net force? Mg upwards. But its mass is 3m. So its acceleration upwards is force by mass g by 3. So here we have two values, two answers. One is g by 3 and the other is g. So let us see the options. Okay. So g by 3 and g are in two options. So they are asking A and B. So first A they are asking A is g by 3, right? This is A is g by 3, then g. So the correct answer here is g by 3 comma g. I hope this is clear. A very good question. Okay, this is a good question. See, let's see another question. One end of a string of length L is connected to a particle of mass m. Other end is connected to a small peg. Peg means like a nail, okay? On a smooth horizontal table, if the particle moves in a circle with speed v, the net force acting towards the center. See, this is very simple. Tension is there acting towards the center, connected to a block particle and whatever it is doing in circular. So people get confused. They think centrifugal will balance it, so net force is zero and like that. No, tension is acting at the center. Centrifugal acts when you change the frame, that is pseudo force. So the net force acting towards the center is simply tension. So they tried to confuse you in this year. Next question, again a theoretical type of question. 2017 again. A girl jumps down from a moving bus. Bus is moving, girl is jumping from the bus along the direction of motion of the bus. Okay, so when the bus is moving, she is jumping along the direction of the motion of the bus outside the bus, tilting slightly forward. She falls on A sheet of ice. Ice is there. And B, a patch of glue. Okay, what will happen? Where will she fall forward in first case, backward? What will happen? This is again question related to first law, inertia. The inertia of the body is going along with the bus. So the girl will fall in that direction because it is the inertia. When the feet touches, okay, when the feet touches the ground, the feet come to momentarily rest, okay, because of inertia. It is in contact with the ground, and but the upper body is still moving in the same direction, so the girl will fall forward. So in both cases, A and B, she falls forward. Okay, so coming to the last question. Oh, not the last, sorry. Second last question. Two stones of masses m and 2m are whirled in horizontal circles. Heavier one in radius r by 2, lighter one in radius r. Tangential speed is n times the heavier. Centripetal acceleration same. Very simple question. Centripetal acceleration forces are same. So first mass m, other one mass 2m, mv square by r, right? Speed of lighter stone is n times speed of heavier stone. Okay, speed of lighter stone is n times speed of heavier stone. Radius, heavier, lighter one in radius r, heavier one in radius r by 2. Now we can solve and find n. So this is 4 mv square by r, I think. Mv square I can cancel, n square equals to 4, so n is equal to 2. Answer is option B. 2015. Very simple, 11 years ago. So we have come to the last question of this one short revision plus PYQ practice. Again in 2015. This type of question we have done. 3 blocks are there, 4 kg, 2 kg, 1 kg. Frictionless, no friction. Force is 14 Newton, 1 4. The diagram is not very clear. 14 Newton. What is contact force between A and B? Again, we have done such question today. We take them as a system and we find this force. So if you take them as one system, the acceleration, we can find it. Net force driving the system by total mass of the system is 7. So acceleration of the system is 2. Now we have to draw either FBD of A or B. I prefer A. So if we draw FBD of A, we have 4 kg here. 14 is to the right. Normal is to the left. Acceleration is to the right. So we can write here 14 minus n equals to mass into acceleration 8. So this comes out as 6 Newton. So the correct answer here is option A. So students, with this we have come to the end of this session. I hope you have learned something. I hope you have gained some confidence to appear in your NEET exams. We have discussed NLM's friction and circular motion in brief. We have seen an overlay, we have seen some critical questions while we were doing the theory part. And then at the end of the session, the last 1 hour, 1.5 hour, we have been just practicing previous year questions of NEET. And you have seen their questions are quite doable. So when you give the NEET exam, be very confident. Okay, if you have watched similar sessions, you can be very confident. You know how to attempt most of the questions, and I wish you all the best for your NEET exams. Thank you so much. That's all for today. Goodbye.